Good evening, fifth grade students. I'm really happy to be here working on a homework video with all of you. We're going to go over, you know, the importance of practicing the problems first, and then we'll show some work on the actual assigned problems, and we'll get into a routine, which is absolutely what's going to help us be the best we can possibly be. It's been awesome getting to know all of you, and the amount of work that you do is top notch. So here we go. This is what we received today. Okay, and so we are going to separate them because you're going to show your work on this paper, and your name's going to go on both. So I'm going to write my name on both, and then you should stop this video if you haven't done so already and solve the rest of these problems on your own on here first. Okay. So if you haven't done that, go work on the few problems, show them on here, and then come back to the video and I'm going to work on them with you so you can see what you did well and what we need to continue to practice. All right, here we go. Okay. So I imagine that you just have your work over here of your problems. So let's get started. Okay. First, I'm seeing multiply 5 times 3 times 2. And I am going to start with 5 times 3. I'm going to write that product right here. It is 15. And then I'm going to bring the rest of the expression down. It's an expression because there's no equal sign. And then I have the 15, so 5 sets of 3 times 2, or 15 sets of 2, and that is 30. Okay, and that's my final answer. I'm writing this vertically, just replacing the numbers that I multiplied with the product so that it is neat, streamlined, and aligned to algebra, the way that you have to write it when you get older, solving equations. I'm going to do the same thing over here. 2 times 4, I find that product to be 8. Bring down the times 6, and I know that that is 48, and I'm good to go. All right. I'm interested to see how you originally solved these because you'll bring both papers in. Your name is on both, and you'll turn them both in. All right, let's get started on some volume. Really, really awesome job with your structures today in class. I was really impressed by your recognition of the rectangular prism and just it was really hard to find volume when we were looking at kind of those irregular figures. So let's dive into some rectangular prisms. All right. Each rectangular prism is built from centimeter cubes. So each one is 1 centimeter. Find the dimensions and the volume. Dimensions are length, which is what they have here, width, and height. So that's just in parentheses, and there's okay. So length, width, and height. That's what they mean by dimensions. And then the volume is the product of all three. We'll get to that. All right. So let's see what the length is. Length, I like to think of as it goes along. And so I have a long L. This creates an L right here. So I'm finding my length this way. How many cubes? 1, 2, 3, 4, 5. So I'm going to record a 5 in this spot. And then I'm going to look at the width. Okay, the width is the distance from the front to the back, right? The thickness. And that's right here. Okay, and that in this case is 2 cubic centimeters. So I'm going to write 2 here, 1, 2. And then the height, the amount from the bottom to the top. Okay, I also have 2 cubes, 1, 2. And then I'm going to take a moment before I even write this as a volume to write it as an expression like we did up here. So my length, 5, times my width, 2, times my height, 2, is going to be my volume. So I'm going to get 5 times 2 is 10, times 2 is 20. And I'm going to put that up here. It already has the units for us as centimeters cubed because we multiplied 3 dimensions, length, width, height. Now, in class, we've been counting these, and we've noticed that, oh, if there's a front side, then there's a back side. If there's a first layer, then the cubes in the back are also filled in. So I do want us to see that this was 20 centimeters by the multiplication and by the number of cubes, let's say on the front, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then there's a backside of those, another set of 10 indicated by these two, and that's also 20, 10 plus 10. All right, let's check out the next one. Okay, I have my volume here. My length alongside is 1, 2, 3. I record it. My width, the thickness, is 2. And then my height from bottom to top is 4. Okay, if I just looked at, what if I just even look at this bottom layer? How many in this bottom layer? I have 1, 2, 3, and then I do have a backside, 1, 2, 3. So there's 6 on this bottom layer. The next layer also has 6, 6, and 6. So already I'm getting the volume to be 6 cubes plus 6 cubes plus 6 cubes plus 6 cubes. That's 6 times 4, which I know is going to be about 24. Let's see if the handy dandy numbers get us to that point. The amount of length times width times height. 3 times 2 is 6. I write it right below. Continue through, 24. Look at that. Right? So I'm able to see it multiple ways, and that's making me a really strong, flexible thinker. And I'm going to get 24 centimeters cubed, 3 here, 3 in the back, 6 total, 6, 12, 18, 24. Okay, so we're really combining 2 ways to see volume here. Visually counting the cubes, and now moving over to the procedure, the formula. Okay, let's take a look at these few here. I'm going to see, oh, you know what? This first layer has 1, 2, 3, 4, 5. And it goes back 2, a front and a back. And then it goes up 2. I'm going to write my expression. And think about it. If I have 5 twice on the first layer, that's 10. And then my second layer is the same thing. That's also 10. 5 times 2 is 10 times 2. 10 plus 10 is 20. And 10 times 2 is also 20 cubic units. Look at the next one. Length. 1, 2, 3. Width. 1, 2. Height. 1, 2, 3, 4. 3 times 2 times 4. 6 times 4. 24 cubes, or cubic units. Look at letter C. 1, 2, 3, 4. 1, 2. 1, 2, 3, 4. And my expression is the amount of length cubic units it goes across times the amount of units it is wide times the amount of units it is tall. 8 times 4, 32. Okay, so I must have, if I have 4 columns, or 4 layers, excuse me, 4 layers, 1, 2, 3, 4, I have to have 8 in each layer, which makes sense. 4 in the front, 4 in the back. Look at this last one. Length, 1, 2, 3, 4. Width, 1, 2, 3. Ooh, that's our first width of 3. And then height, 1, 2, 3. All right. If I even just look at the layers, let's think about it. Layer 1 has 4 across, 4 down the middle, and 4 in the back, indicated by this. So that's 4 plus 4 plus 4. Layer 2, same thing, also 12. Layer 3, also 12. Let's see what happens over here. 4 times 3 times 2. Here's my expression. 4 times 3 is 12 times 2 is, nope, it's 12 times 3 times 3. That is my mistake. And so it is 12 times 3, which is 36. And that's absolutely what you would get if you added the individual volumes of each layer and if you multiplied the 3 dimensions. So we have 36 centimeters cubed. In this way, we are able to, like, combine our knowledge of counting the cubes, identical layers, and this idea that if it's too large to be able to count the cubes of it, I know if I measure the length and the width and the height, I can multiply those 3 numbers to get the volume. Like I said, we're doing really, really, really good job with volume. And I know that Ms. Musa and I are really excited to continue to work through this. Have a great night. If you have any questions or anything, emails and phone numbers are in the email that your parents got. And we'll see you tomorrow. Night, night.